And I'm back. You ready for another quarantine vlog? I'm ready. Just getting in for the day. Had an idea to show you guys. So most of the time, I bring my laptop home every night. I use my Autodesk backpack that I got at Autodesk University because I was a speaker there in like 2016 or 17, I forget. I got the backpack. I freaking love this thing. And more importantly, the laptop that I'm using is a MSI gamer laptop. It's a, don't quote me on this, but it's a GE71 something something something. It came with 16 gigs of RAM. I put in 32 gigs recently, and that made a huge difference in performance. Otherwise, it's basically stock. It's got an SSD, an M.2 SSD, and I love it. It's a 17-inch laptop. It's light. It's very, very light compared to most 17s. And it's got a number pad. I love programming with a number pad. It would drive me crazy to have a laptop that didn't have one. So usually I bring it home every night, get some work done at home, bring it in every day, get some work done here. I don't really have a desktop set up at home. My son stole my home computer, so that doesn't work anymore. But yeah, eventually I might do a desktop setup here. I just haven't yet. We have one over there actually, but that's more of like the shop computer. That's not like my computer. I like having all my stuff on my computer and bringing it with me both places. However, like almost everything's on the cloud now. So use Google Drive for all my documents, all my posted codes, all my edits. Fusion is all synced and everything. So I could probably do, but I like to leave stuff open. All my tabs are open, all my Fusion stuff's open, and mixing that between two computers is a little trickier. But anyway, yeah, I got some good stuff lined up for today. I love these things. Get them from Amazon for like under $10 each, whatever. So I buy a bunch of them. I have one on the Swiss, but I dropped it in the oil and it kind of stopped working. We tried to ultrasonic it, but it had oil inside and stuff. So I stole the one that I have at home, and then I'll have to replace that one eventually. First things first, yesterday I had this dropped off. So when we ship our Saga pens, we ship them in a sweet, sweet custom-made wooden case. We don't make them, a local company makes them for us. They designed them, we approved it, we tweaked back and forth and everything. They've come out with version 2 of the design, and I just saw this for the first time yesterday. I'm really happy with it. I think it looks awesome. And it's got a magnet slide attachment. It's kind of captured in the dovetails or the rails, whatever, so that the lid doesn't go further. The pen and the ink are stationed in there, and it turned out real nice. Super duper nice. Made by Millworks, M-I-L-L-W-E-R-X in Beamsville, Ontario. They did a killer job. So if you need any woodworking, hit up Matt and Millworks. Yeah, I'm happy with this. So here we have the bearing cages that I make for our pivot bearings in the knives. Okay, I make these from a long half-inch round bar of Delrin, and I drill and I ID bore and I turn the outside and I put chamfers on the outside, and then I transfer it and then I cut off, and then I come in with a little tiny lollipop end mill, and I'm actually contouring the inside of each little hole. Let me grab a piece of paper and show you guys. So each hole is not just like that. Each hole is actually like, it goes down and then it goes up, and then that's the surface. So each ball bearing is actually captured inside the pocket, which just makes them work better. And that is one of the secret sauces to our knivies being so butter smooth, and especially having that drop closed action that they're known for. Yeah, so we make our own bearings. Very few guys do that, and it's pretty awesome, something I'm really proud of. The ball bearings that we use are ceramic, and they're grade 3 ceramic. They're the highest grade that I can find anywhere. They are made in the US, which is super rare. Most of them are made in China, and they cost about 25 cents each. So, I mean, that's a few dollars right there. But this is probably $1,000. Isn't that crazy? I've just got it in an Iskar Call It container right now because it's just a nice little container. But yeah, probably at least $1,000 in this little jar right here. That's nuts. So don't sneeze. So what we do is first we go through and we make sure that there's no little flappy burrs. So we put them on this little fixture, feel them. I can tell the fixture's wearing out. This thing's a couple years old and it's not being as effective as it used to. It's also dirty. That might help. So we do that, and then we've got a bunch of different ways to do it. I used to pour out the bearings and then press each one onto the balls. I could catch like 2 or 3 at a time and then just pop them down pretty easily. But Angelo came up with a sweet way where if you grip it with the tweezers like this and you dip it in the container and jiggle it around, you can usually catch them all. As long as you don't drop it. And then you take a little block of aluminum and you just pop them down. Done. And then I feel them with my fingers, make sure that it rolls nicely, and then we go through and do it again. Done. Sometimes we'll do 2 or 3 at a time. Although if you get more than 2, then the pressure becomes a little awkward, a little hard. Come on. Boom. We did, I remember a while ago, Sky and I were playing with a pneumatic press that I made. So he'd line up like 10 of them and then use the pneumatic press to press them all down. And that worked really well. I don't know why specifically we're not doing that. Normally some of the other guys do this job, but since I'm the only one here today, then this is what I get to do. Eric said he's all out. Eric's in the front building, putting together knives, doing his magic. So I'm just gonna bust out a couple of these and get them set for a little bit. And then I bumped it and they fell out. So that's what the tray is for, to catch any fallout. Ah, bounced him again. So I've been making the bearings like this for, when did I even start? I think I started at knife number 42 or 44. I kind of remember that. Before that, we used the Alpha Knife Supply bearings, and I was like, I can do better. So yeah, we've been making these forever, and I've been assembling them using a couple different methods, but this is the best we've found so far. You know, a lot of guys always suggest like robots and pick and place and stuff, and yeah, but this works fine too. No, but it gets me thinking that as the business has grown, and we now have 8 employees, including myself, working here, although not now during quarantine. We've sent everybody home. We're still paying everybody full 40 hours a week, even though they're staying home, and that's a choice that we made to take care of our family. But it's interesting for me to kind of dip back into all these jobs that I have passed on to the other guys, and it makes me realize how much infrastructure is in a business like this now. In an 8-person business, we make, you know, a good amount of money every year. And it's an expensive business, and there's lots to do, and there's always work to do, and there's always little projects and things to fix and things to break and things to redo, and not only that, but just the work, the effort involved in assembling all these bearings. It's not fast, but it's work, and I wish there was a faster way, but for now it's a good thing to keep someone busy for a while, to keep them active, to keep them paid and useful and helpful. And we only do it like once a month or so, but you just sit down, put some tunes on, or I don't care if the guys watch a show or something. Usually I'll bring this home and like put on a movie and just assemble bearings at home. It's got to get done. So, but yeah, it's weird to think to now take back some of the jobs that I've allowed others to do and just realize how many there are and how much it takes to run this place. It's humbling. It's cool, and I like it. And I'm looking forward to the day when everybody can come back, and even if we stagger it, like, you know, start introducing people back slowly. I'm just looking forward to getting everybody back and get this place rocking again. Like I said in my last video, working on pivot screws, pivots, Norseman pivots on the Tornos. Been spending a lot of time on that lately off camera, and finally made really good progress. They're coming out amazing. I'm doing some pretty cool stuff. I'm actually using a grinding wheel to face the front of the part. Let's find an example here. So there, the little Norseman logo guy. This one was turned and then polished on the stones, on the PFG stones a little bit. Not the prettiest face, but anyway, I'm using the grinding wheel now. There you are. To basically face the front of the pivot like that. I'm rubbing up against it, and then I'm coming in and I'm slicing it down to center. And after a lot of testing and probably 40 bad pivots, they're looking so good. So let's go to the microscope. I'll show you what I've been doing, and then we'll turn off the machine and I'll show you the setup on the machine too. It's awesome. But before we do that, we have to fill up the whey oil in the Tornos, because it's just about to complain and alarm. And if the oil level gets too low, then the whole machine kind of stops at the next cycle and just sits there. So I'll show you the pump lid that I got from, pretty sure I got it from McMaster. It's amazing, everybody needs one. On a wheelie cart that I got from Uline, rolls around, this is awesome. So my one barrel is empty, I'm gonna swap over to the new barrel and load it up. So I think I got a little bit too excited there and I filled it right to the very tippy top. That was a dumb idea. Now I can't get the cap on. But anyway, what I wanted to say was every machine will tend to have some sort of oiler like that. Some of the lower end machines will have a pull activation thing, so you have to go around every so often and do it. The auto oiler is amazing. Different machines will go through different amount of lubrication. The Swiss, when I'm running it hard, I only fill it like every few weeks, whereas the Nakamura, when we're running that hard, I gotta fill that thing every two times a week maybe, which feels like all the time. And this one is right down there. Check this out. The cap likes to stick, so I actually 3D printed a cap gripper. Next time I'll make a longer handle one, but it helps a little bit. But if the handle were much longer, it would just make it that much easier. But yeah, fun little 3D printing hack. Oh, I also did this one. Air gun holder with, if you can see it in the light, air gun printed in, Viking logos on top. Hard to tell. And then pretty sure it's double-sided tape to the machine frame. Aha, we have success. If I shake it a little bit, you can see the level's not to the tippy top, so I'm actually able to get some air bubbles to the top and lower that level a little bit. So a couple episodes ago, you guys may remember,
I told you that a guy sent me a microscope adapter for a phone. Well, I went digging and I done found it. So, he sent this one for my Galaxy S9 with a bunch of different lens adapters because he wasn't sure exactly what size would fit on my eyepieces. But let's try this out. I had to take my case off, which took like a second, and then the phone clicks in nice and good, and then this is going to slip right on. So let's see here. It's on there. Let's take a peek. Whoa, this is working. Okay, I gotta say, this is actually really, really, really amazing. Hey. There we go. Look at that. So when designing this, he obviously had to take into account where the center line of the camera is and align it to the center line of the lens, because I plugged that in and it's almost, it's not like dead center, but it's almost dead center. And actually, I bet you if I tilt it a little bit, it helps a little bit, but it is a little off, but that's fine. It's good. It's good. Okay, let's go into the camera and let's see what that looks like crisp. Now, a lot of these microscopes do have like a camera built in. You can hook up a TV to it. That's on my wish list. We will need another microscope eventually because I use this thing all the time, and a TV would just be amazing. All right, so here's what we're gonna do. I'm gonna talk to you, but this is gonna record. Ready? And sync. It's so weird not putting my face like right up to the lens. It's nice. Okay, so here is the problem I've been having with the pivots, is I'm turning the face as good as I humanly know how, and then I hit it with the PFG stones, and then, so you can see the center and the outer ring have been stoned flat, but there's this dish around the inside periphery, like, that just won't go away. And I've tried, I mean, I'm telling you, I've tried different speeds and feeds, different depths of cut, 1 pass, 2 pass, going backwards, going forwards, sharp insert, new insert. I haven't tried, I want to try a CBN insert, which is a cubic boron nitride insert. I haven't done that yet. That sounds pretty awesome. But it's driving me crazy, and it's just super annoying. So let's go freehand here. Show you some details of this pivot. That little chamfer right there is not super easy to do. I'm using a back chamfer tool to do that. The surface finish on the shaft looks pretty darn good. I'm happy with that. Sometimes you can see clamping marks from when the subspindle, call it, grips it. My focal range is really small. I can't move up or down too much. Nice chamfer on the threads right there, using a spot drill. Threads are good, 3B tolerance, little radius at the front of the part. Chamfer actually. Well, I think it's both. It's like a half radius that turns into a chamfer. Head thickness is good, outside chamfer is good. Flat width, the width between these two flats is good. Zoom out a little bit. Give me a bit more breathing room here. Engraving looks amazing. It's just that face finish that's driving me nuts. So, what I've done is, and Fraser, feel free to jump back and forth between these two video feeds. What I've tried to do, what I have succeeded in doing is, it's not the best example because I made a mistake on this one. However, like I said, I've installed a grinding wheel on this one. Now this pivot is showing a mismatch between the facing tool and the grinding wheel, which I've since fixed, but you can see it's got like the difference. But anyway, let me get a good pivot out of my green bin of good pivots. I'm going to clean it off on a paper towel. I'm going to clean it off on this sticky tack that pulls all the garbage out. Let's take a look at this guy. Where's my fingers? There we go. Oh, baby. Oh, that finish is stellar. Oh, so good. So yeah, that's happy. I'm happy with that. Let's compare it to the turn finish from before and put them nice and side by side. Zoom me outie a little bit. Yeah, that's better. That is significantly better. Back to the main camera. Using my PFG stones from kineticprecision.com. No affiliation, just a huge, huge fan. I love and hate these stones because I love them because they're awesome. I hate them because they show everything. No more secrets. No more hiding. So I'm going to go on the dark stone, the rougher stone here. Should be doing figure eights. I don't know if it matters, but... And then we'll see on the microscope what that actually just did. I haven't cleaned it off yet. Okay, let's clean it off on the paper towel below. Clean it off on the sticky tack. Okay, so you can see what it did. It hit the center and it hit the outside a little bit. So there's a little bit of flatness imbalance. And there's still kind of a dish in the same-ish area as before, but I think it's better. I think it'll be great. And yeah. So I've made a good handful of these. Next step will be to put them in the tumbler because we like having a tumbled finish because it hides all this little garbage that you can kind of barely see. And we want full Grimsmo on everything. So not only am I trying to make the absolute best finish there is, we're destroying it by stonewashing it and putting it in rocks and making it even and smooth. But that makes it look really good. And that also exposes all of the hidden scratches and lines. Yeah, so I'm gonna go test that. I don't know if I'll film or not, but that's good. I'm happy with that. All right, real quick, I want to show you guys the grinding pin, the grinding device that I'm using. This is made by Cut. I found it through a whole bunch of research. I actually bought it to grind the Rask bevels on the Kern, so I just kind of had it and hadn't tried it yet, and I really wanted to try it. So actually you can see it's wearing unevenly. So the dark section on top is doing the work and the light section on the bottom hasn't quite hit yet, but I think eventually it'll wear in. It's working really good. So let's take a scrap pivot, just show you guys what it's doing real quick. The parts in the spindle's rotating at 200 RPM against this face. This guy's running at 8,000 RPM, and it feeds in super duper 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 slowly, and then it goes up, and then it does a couple finishing passes down, and that tends to leave a really good finish. So I'm happy with it. Just got a sweet mail call gift from Bastian at GorillaPod. Oh, there it is. Anyway, this is a tool holder mount to be able to undo the colic nut on an ER16 or Cat 40 or whatever. So he sent me a Cat 41, and it's gorgeous. Fits perfect. He sent a really nice letter with the package. I really appreciate the letters. I put them up on the wall, and he basically said he sent one to me, he sent one to John Saunders, and he said thank you guys so much for all the content, all the tips and tricks you've been putting out for so many years. our inspiration has caused him to start this business and do this. And I have seen these around Instagram. I'm really excited to have one. So thank you very much, Bastian. I'll make sure to send you an email as well. So yeah, we've been using this one. I bought this guy on eBay like 5 years ago. It was cheap, but it works well. Now notice how I've got this one mounted sideways, because putting the tool in goes in this way. I like it sideways because then your tool doesn't fall out. That's the one thing I don't like about a flat mounted unit, is when your tool goes in and you start to loosen it, the tool will fall. I don't always have a stopper in the bottom of this. I don't like them most of the time. So I don't like that. So now I've got both. Now I can mount one sideways and one flatways, and we'll see what I like best. It is 9 o'clock at night, and I finally get to play a couple hours on that thing. It's gonna be a late night. Right now, I'm gonna set up some tools. So this Kern uses an HSK40E mounting taper, a spindle taper. Much different than the Cat 40 that I'm used to, which is much bigger. But it's got an internal gripper thing. So the gripper goes in there and flexes outward. So at super duper high RPM, the centrifugal force actually opens it more and creates a more secure bond. Whereas a Cat 40 taper with a pull stud, the higher the RPMs go, the outside clamping kind of loses a little bit. So that's why you don't see Cat 40 with a ton of RPM. It's a dual contact design, so it's taper face there and face contact as well, super duper accurate. And on this machine, obviously I went with the RegoFix PG system. So I've got 4 different mounting sizes. I got a PG10 by 80 millimeters long, PG15 for the little bit bigger tools, PG25 for the big boys. I think that's a 3/4, well, the collet that will go in there can go up to 3/4, maybe an inch, probably just 3/4. And then I also got some ER16 for my random little stuff like the drill bits and the reamers and things like that. So the way they work is really cool because ER collet is just like any ER collet. It's a taper collet inside, but the PG system uses a very specific end mill diameter. So this is a 3/8 collet. It will only fit a 3/8 end mill, which we have right here, and it is a butter smooth, perfect fit. And then also, this is I bet it's a little bit of a taper, but maybe it's straight, I'm not sure. But it's a press fit design, and the machine that I'll show you in a second presses the collet all the way to a specific height in the holder, and then that compresses it a little bit and holds the end mill perfectly. So the tolerances they achieve to do this is insane. But it becomes one of, from what I've heard, like everybody absolutely loves it except for the price. They are more expensive than an ER or a shrink fit or some of the other systems out there, but otherwise the rigidity, the run out, the accuracy, the quality, super duper top notch. That's full Kern right there. So this unit right here is the RegoFix power grip station, the pressing device. So it comes with these dies, or whatever you call them, clampy thingies, that wrap around the tool holder and grip the collet in the holder and separate like that. So this is a whole hydraulic unit that goes near. I'll show you. So I got to switch. This is the 15 holder. I think I have the 10 in there right now. Turn it on. This is a two-handed operation. Comes with these paper wipers to go inside, like so. Keep everything nice and clean. Check this out. It actually comes with a box of these official RegoFix papers. So they got different sizes, one for the 10, one for the 15, and I'm sure there's another one for the 25. So in the last video I was talking about how the stick out has to be the same as what's in Fusion, the same as what's on the machine, like everything has to be the same. So as I'm putting this guy in there, I gotta make sure that I stick it out whatever I need to, either for the tool or what I've designed in CAM. So I've got on my Post-it note written 1.1 inches, which is, right now is 1.06, 1.095, and it's gonna move a little bit here. So I'm still trying to find like the absolute best way to do this. My buddy Rob suggested O-rings, like get a 3/8 O-ring and just kind of shove it over the diameter of the end mill, and that's going to keep it in place. Because in the machine it's vertical, and the tool just wants to fall down. I've got a bit of this blue sticky tack, a little corner of it, on the RegoFix design right here, that I kind of shove in there, and that holds it in place. So this is what I'm doing for now. O-rings would also be a good idea, so I might get some of those, but this works. Okay. So this guy goes in here. I can tell the machine's in the open position right now. It will hang, but I don't want it to fall. So I'm going to close the door, lock it down, and then I've only used this a couple times, so I'm still kind of new at this. So if I look like an idiot, it's because I kind of am right now. Yeah, there's an E-stop, there's an up and a down button. It's really not that hard. So I'm going to push the in button. And let's see if we can get a close-up of this. And that's about all there is to it. Let's open the door. See, I don't want it to fall or be bumped or something, but you can tell my coupe got squished, but that's okay. Looks good. Looks good. So the collet, so you can tell the collet doesn't sit all the way down. It's not supposed to. That's good. I'll check the measurement again and then move on to the next. And time lapse. All right, running out of time for today as usual. However, if I can get this tool loaded and do at least one tool path and machine something, I'll be ecstatic. And I'm going to stay until that's done, I hope. Oh, I love how the light turns on. Okay, so pretty sure this is tool 100, but I'll check again, put it where it belongs, and then we'll touch it off. We'll figure out the length, the diameter, and with the laser setter. It's pretty cool. So I was right, this guy is tool 100. Let's find that. It's way over here. And this is what's it called? HSK 40E. There's no orientation on this particular holder. I could put it in any which way. The tool changer doesn't care, the spindle doesn't care, but with regards to run out and consistency and keeping things normal, I'm always going to put the logo facing forward because there's no other logo anywhere else. So I'm going to put it in the tool changer like this, and then the robot arm is going to grab it always, put it always in the spindle in the same way. Just keeps that consistency. There we go. And basically this here is the robot. There's little gripper arms right there. And this whole thing travels across. I can move it with my hand. And it's just a big XY platter. So the next thing I have to do is I have to tell the machine that I just put in tool 100. Okay, wake up the screen, so Let's see, tool table. So I would go down to tool 100, and I'm going to type in the tool name. I'm going to give it a rough length and radius, and then I'm going to scroll over. This thing's just a giant spreadsheet with all kinds of, there's even a variable for current time in the cut. There's a variable for last time it was called, angle, tolerance, direction, right offset, left offset, or radius and length, I guess. Breakage detection options, lift off, angle, last used. Last used is cool because it's a date field, the date that the tool was last used. All kinds of stuff. Most of it's not important for what I usually do. But yeah, so I'm just going to fill this out, and then we'll call the tool and we'll laser it. All right, let's call tool 100. How cool is that? Super cool, right? So in the Heidenhain 640 control, they make it pretty easy to do tool calls. But what I just did was tool call 100 on the Z-axis with a default spindle speed of 10,000 RPM, and that's it. You scroll to there, hit cycle start, we're good to go. Now the cool thing about Heidenhain that I really like is this is your MDI screen. On a Fanuc machine, your MDI screen is like, you can type a couple things, but the second you run it, it disappears. These all stay here. So all the ones you use all the time, touch probe setting, measurement cycles, spatial coordinate, polar interpolation, what are they? Not polar interpolation, I forget what it's called, but probing at an angle basically. Different tool calls, touch probe. You can tool call a name as well, tool call touch probe. All this stuff you normally type in, and they make it very easy to type in. Like for example, if I go here and I go tool call, it opened up that yellow line and I go 100, enter, and it asks me for a Z, and I say yes, and then it asks me for a spindle speed, and I'm canceling the rest of that. That's all it is, and then I can delete it and we're done. And it keeps it for next time, so that's really handy. Okay, so now I'm gonna find one of these and do the tool laser thing. Actually, it was this one, the one we were looking at. Touch probe, tool setting, length and radius. Measuring type is 3. If we scroll down, oh, there we go. So type 3 is measure. And then if we scroll down again, application, you can go length, like I'm just saying, there's lots and lots of options. And they make it super duper cakewalk easy. And it remembers it for next time. So it's moving sideways into the laser right now. Very slowly, both directions. Goes through on the other side of the beam, comes back. It's trying to get a perfect diameter from both sides. I think we're almost done. Oh yeah! How cool is that? So, let's see how close we were. Tool table. 4 point, this is the exact, oh look at that diameter. Just under an 1/8 inch radius, so a 1/4 inch diameter, that's perfect. Oh, I forgot. Very, very important. Open the door. Now this is a new end mill, I just pulled it out of the package, but Kern actually provided me with some fancy green German sticky tack, and they suggested the first time you measure your tool, if you want Kern precision, to literally go in and clean off every single flute of every hair and burr and dust and little garbagey bits, and then probe it again, or do this the first time. And then I bet you if we do this, we'll get a different diameter right now. Maybe. All right, let's try that. Make sure I didn't leave any green on there. Okay, let's try it again. Same thing. So, remember this number, 12489. 12489. End, MDI. Up, same tool setting as before. That's it, everything's good. Okay, I'm just gonna hit cycle start. All right, doing the length now. Just a straight plunge. Now it's moving over to do diameter. Get it from the other side, we're almost done. Pretty sure we can go to the tool table and watch it update. 2488. Wait, 12489. Okay, that's like 1 unit of the 5th digit. Okay, so it didn't change at all. I mean, essentially. That might just be the tolerance of doing it again and again. But that's good to know. This is the kind of stuff you gotta learn, you gotta test. You got to come up with a standard procedure so that you always do it this way. Next up, I'm going to mount my hunka heavy steel here, and then I'm going to torque it down, and then we'll probe it. We'll use the touch probe, and we'll get this thing dialed. Somebody asked me once recently if I'm scared of this machine because I'm taking my time so much, and truth is, no, I'm not scared of it. I have a healthy respect for it. I'm excited, but I'm a little nervous. I want to focus. I want to be able to focus and take my time, yet I'm still distracting myself trying to run the Mori, trying to run the Tornos while playing with this on the side. But the truth is, no, I'm not scared of the machine. I'm scared of that heavy chunk of block doing what we're about to do to it and it falling. And this is the next operation that I've been needing to do for weeks now, and putting it off, to be honest. I'm a little scared of this operation, not necessarily the whole machine and all that stuff. That's exciting, but it's just nerve-wracking the way I'm holding it in from the inside. I'll show you again. I showed you in the last video, but I'll show you again in this one real quick. So if we go hand wheel C, we can rotate the C axis. How cool is that? I feel like I'm saying how cool is that a lot, but it's true. Okay, so we're dovetailing it. I machined a groove on the inside of that pocket, so the dovetails are gripping onto something. They really are, even though maybe it doesn't look like it. But basically we're gonna tilt it this way and we're gonna tilt it that way, so it's gonna hang on the dovetails. And it's just freaking me out. I've just never done it before. So I've got, the first time jitters. All right, so to do everything as right as possible, I'm gonna torque it down to the vise spec of 55 foot-pounds. 55, okay. Double station vise is weird because one side tightens clockwise, the other side tightens counterclockwise, or anti-clockwise, because it's got a screw on this side and on this side. So I gotta make sure I'm actually tightening and not loosening one side. So I'm gonna home the machine right now using that button, line, L for line, B0, C0. So that's, actually let's make the B a little crooked here. Oh yeah! Okay, so back to MDI, back to B0, C0 at F max, so this is full rapids. I've got my feed rate knob at 100, so this is gonna scoot pretty good when I hit cycle start. Oh yeah! So good. Okay, so now we're gonna get the touch probe. So to remember right, touch probe I believe is tool 10. Calibration pin is tool 10, touch probe is tool 20. So I need an MDI for tool 20. Let's see if I have one from before. Maybe not. Finally! This is the last piece of foam. We've been running foam for days. Perfect time because we're, you know, down, not doing too much. Dun 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 dun. And if you'll notice, these are not a Norseman shape. These are a Rask shape. I figured since we have the foam, let's make a whole butt ton of Rasks. And this is all Norseman, plus there's another box somewhere else. And we're out of foam. Good, good, good. But oh, good gracious, this thing's a mess now. Take a while to vacuum this thing up. This is the worst of it, right up here. All this, ugh. That's not good. So, as I said, one of those two machines is going to be dry, the other one's going to be wet. Those are going to be the foam machines. They just need a little bit of work. We'll get to it. Now, back to this. Actually, what I wanted to do was turn the vacuum off, turn the machine off. Good night, machine. Now back to this. Okay, probe, T. So, I can simply go tool call, brings up a new line, 20, enter, Z-axis, spindle speed, I'm going to do 0 because the probe is 0, feed rate, and then I can just do an end, which skips all the rest of the stuff. But the probe is actually limited. There's a setting in the tool table that says do not spin this thing at all. Because obviously you don't want to spin the tool probe at any RPM. I don't know where it is. It's in here somewhere. Maybe it's actually in the sub-menu. Okay, so if I call that, it should tool change to the probe. So you can imagine right now the robot is going around grabbing the touch probe, bringing it back. Maybe I'll get a shot from the other side of that. And then it's going to swap out this tool. That is getting awfully close to my block there. I mean, it's fine, but the bigger your workpiece gets, the more you got to really watch that stuff. Well, let's just make this video long, why don't we? Energy, lights, tool mag, lights. That should have turned on the lights in the thing. Check this out. I can pull this guy around. Except it hits there. Okay, lights are on. We can kind of see what's going on. So I'm going to call up tool 100, which is right there. And we should be able to see some action if I give you this angle right here. So I'm just going to scroll up to the 100 line. I'm going to hit the sickly starty. Ooh, I don't get to see this very much. Okay, it's grabbing the tool. And then over here, oh yeah, oh yeah. Put the probe away. Where are you? There you are. Oh, that's so cool. And then it's gonna park it. That was awesome. Do it again from this side, because obviously I need the touch probe in here. Alright. It automatically turns the probe on to that little sensor right there. So when it's in the spindle, it's on. So don't leave it in the spindle for like days. Otherwise you'll drain your battery. Okay, so the probing operations in Heidenhain are super nice. So beautiful. So I just go to the hand jog menu. There's a touch probe button. And it gives you all these options. It's all very graphical, very amazing. Let's say I just want to do a Z probing. I can probe, it's a single line in any direction. So I'm going to go Z minus. I got to jog it to over the workpiece. I mean, we're going to clear, but it's a little tight. There is a hand wheel here, which if I go to the hand wheel button, this is awkward with one hand. I need a tripod out here. I have the GorillaPod, but I need a tripod. Anyway, I gotta set this up. I can't do this. Too many hands. I was actually totally wrong. That's probing plane. I don't want probing plane, because the graphic, I was wondering about the graphic, it confused me a little bit. Duh. Probing position is what I was trying to do. It's just a simple Z probe. I can still choose whichever axis and direction I want to go in. Z minus, and then let's give a little zoomy here. Hit cycle start. Try to get it to focus. Probe goes down, single touch, done. And then we just go set preset and end, and then we're 83 thou above the part. Looks about right. First step done. So the next one's a little bit trickier, but like that much trickier. Probing center line. I'm gonna do X. I gotta jog it to gotta jog it to there. Gotta go down so that I hit the part. That ball is so tiny. It's hard to even see it. Okay, so yeah, that'll be good. So I'm going, yeah, that is X plus, so I'm going in X plus first. And then I just hit cycle start. So now it's paused and it's remembered that datum, and it's asking for a second touch point, which it defaults to now X negative. So I'm going to jog it up and over to X negative, and I can go in the back of the part and the front of the part. It doesn't matter. So I can actually tweak a little bit of twist like that by going in different spots. So as long as I go on the other side, I can go anywhere and touch it off. All right, we're getting there. So the machine obviously knows where dead zero is, zero of rotation and angular and everything. So the touch probing that we just did in my zero offset, X is off by 35 thou, Y is off by 25 thou, and Z is whatever, 6 inches off whatever the zero is down there to the top of that. So that's fine, I don't care. Now it knows. So this is where it gets a little tricky. Okay, so what I did, this is my block, I probed Z, X, Y, now it knows where center is. The trick with the 5-axis is the second you go whoop, then your X and your Y and your Z have now just shifted in different directions, and there's a planar spatial something move, one of the codes that we saw on the MDI screen that fixes all that for you. Now when I have the Kern guy here training me, this is what we have this for, you know, C rotation, A, sometimes there's an A, there's no A on this machine, B. Actually, this is a test block showing you which direction A would be or B would be, and then C. Anyway, he showed me how I can rotate off axis and then probe, but it writes as if it were here. So you're probing this way, but it writes the offset like it were this way, and I need practice to be really comfortable with that. I wrapped my head around it when he was here, but that was a little bit ago. However, I think having probed the top, my code in Fusion running through Complete and everything does that planar spatial tilty thingy so that as it moves, it's going to know still where it is. Pretty sure. All right, so going from Fusion, I'm just going to output the one single toolpath. This adaptive clearing, super duper light step over. Notice how the chunk is sideways. So I posted that to Camplete, and I imported to Camplete. Camplete's got my entire Kern model with the enclosure and everything. Look at that. So here, if we play it, see the movement? This is what I'm talking about. And side note, I know my buddy Rob is going to smack me that I haven't properly defined my tool. See how it's sticking out? That taper is supposed to be up in the spindle more. So something in Camplete, I got to figure out a setting to be able to move that tool height up to the proper height, because this is simulation software. This knows every kinematic movement of the Kern, and if I'm giving it bad information, then it's not accurate. So for this operation, it's fine, but if there's anything more twisted up, then the spindle would actually be closer to this than what I'm telling the software that it is. So that's not good. So I'm knowingly being stupid right now, but got to get that fixed. But yeah, it simulates, it goes through, and it literally eats the code and simulates it. If this were going to touch, it would tell you. And then I can post it from here, USB stick it, USB into the Kerny, and then we'll go. All right, I think we're ready to go. For some reason it called absolutely the wrong tool. That's tool 7. I want tool 100. What the heck? I opened the wrong code. Okay, I got it. I thought I had it right the first time. I looked at the right one, I clicked on it, but I actually clicked on the other one and didn't realize it. Playing with the feed rate knob to slow it down as necessary. So now that I've carefully watched it walk around the part a couple times, I was worried about the stock being slightly wider in one direction and taking a heavy cut or something stupid. I've seen this, I've done this before in other machines. But now that I've seen it go all the way around confidently, I know that it's just going to do its tool path right now. Nothing surprising is going to happen. It's good. It's good. I got the feedback up to 100, pretty much. So the coolant is slightly easier to see through than the oil, which is running right now. But the oil's at least kind of clear. The coolant's pretty milky. It's going, yes! Look at it chunk through this code. Actually, it's not going that fast because it's all linear moves. We are 5-axis cutting. Can't let YouTube have all the fun. Well, let's do some Instagram stories. Oh baby, 5-axis. Filming for YouTube. That's at night. It's almost midnight. Worth it though. So worth it. Like I said, I've been putting this off forever. It's good, man. I used to dream about this. Owning a 5-axis, making cool parts. Man, I still dream about this. So while that's going, we've finished the foam. Let's check on the Tornos. The parts have been going really good. It's been running for hours now. I've emptied it a bunch of times. This is just the last little run. Let's see, it's been, wow, 4 hours, 19-minute cycle time that I haven't stopped it. That's cool. Bunch of good green parts, I love it. Bunch of bad garbage from testing today. I'm sure this one's bad. But yeah, she's going really good. So you be the judge. Which one's easier to see inside? This one or the Kern? I think the Kern. This is like slimy. Just from the oil. The coolant washes away pretty clean. And you just can't film in this. But it's going good. Things are good, man. Things are good. Got my little army of tools lined up here. I only got as far as the one that I need for today. Because I'm like, I don't have time to do all this. I'm not even going to use these tools today anyway. So why waste time today finishing the setup of them? Check out these moves. This baby can dance. That's fast. That's a really fast, rapid movement. Holy crap. So this is what we're making. It's the bottom mounting drilled holes and alignment pins for the tombstone. So this is the tool path that's running right now, but while that's running, I'm gonna pull a Phil, my buddy Phil, who says he likes to just output the first op, throw it on the machine, start running it, and then come in and program the second op. So I've got all these tool paths that are fairly simple. I just need to get rid of some extra material and face down the top of those pins because they're going to be, the material is quite tall still. So I'm going to program those real quick, or just output them, make sure they're good. Ladies and gentlemen, we have a part. Whoa. This is a roughing pass. I did a super light step over and oh my gosh, I don't know if I can feel bumps. Maybe ever so slightly. A little bit of weirdness, but I mean, dude, that was a roughing pass. Wow, it's shiny. I can see myself in... Holy moly! People aren't kidding when they talk about Kern finishes. What the heck? It's a mirror. Look at that. What the? The tool I used is made by my buddies over at Milterra at Zidaro. Nice, holy moly. What the heck? Anyways, guys, that's it for me tonight. I can sleep happy. That's so good. So good. I hope you guys enjoyed. I enjoyed. It was a long day, but so worth it. Okay, I've gotten over my fear. I made the thing that I've been worrying about for so long was just roughing that material away. It's literally no big deal. That was fine. Now I just have some more finished work. I gotta drill, thread mill some holes, do all that tomorrow or the next day or whenever I come back. But yeah, anyway, thanks for watching. Take care. Bye.